All right. Hello, Facebook. Welcome to the Facebook Live tonight on Number Talks Remotely. So I'm going to be talking about remote number talks tonight and how we can do number talks remotely when we are doing, I'm going to focus primarily on live synchronous working with students. So not so much remote where we're doing asynchronous, where we're videoing things ahead of time. This is more when I get kids on a live Zoom or a WebEx or a Microsoft Teams event where I've got students kind of live with me and we're going to do a number talk. So there are some really important reasons to do number talks this year more than ever, because this year more than ever, we have some unfinished learning that we know happened at the end of the last school year. And so because of that, we know we have students that are sort of all over the place, right? We don't have students that are kind of at one place and we can just teach one thing to them. We've got students that are kind of all over the place. And so we need to do tasks that are open enough, not really low threshold, high ceiling, but just low threshold enough that as students are in our classes are really at these different places, we need to do something where all students can enter. They all have access and they can all learn and they can all grow. So number talks fill that bill really well because we can ask a question that students can enter using what they know to solve the problem. And then as we ask students to share their strategies, the teacher represents those strategies on the board so that we can then compare those strategies, so that we can help make the thinking visible for students so that we can have conversation as we compare those strategies. It gives teachers really good information about what the students know. So I'm really curious about what my students learned last year. I know there's a lot of unfinished learning because of the pandemic and COVID-19. So honestly, no matter what the year is, but especially this year, we know we have a lot of unfinished learning. And so a problem talk can be, oh, look at, I just called it a problem talk. So a lot of people call them number talks. Okay, I get it. Often the things that we talk about are problems with numbers in them, but they're really not talks about numbers, right? Like typically if I was maybe a kindergarten teacher, I might have a problem talk about the number 6. Okay, cool. Then I could call it a number talk. But for the most part, I call them problem talks because they're kind of talks about problems. I can do what a lot of people call number talks with problems that have numbers in them, but I can also do problem talks with algebra and geometry and statistics and all sorts of topics. So it's okay. I call them problem talks, but problem talks, number talks, either way, it is throwing out a problem to our students and then seeing what they can do with it. It should be a problem that all students have access to so that all students can be successful. They all have access. And then I'm going to challenge some students to find the most sophisticated way, the most clever way. Ooh, can you find something even more clever or efficient to do that can help keep these kids going while these kids are solving the problem? Gives me as the teacher really good information about the kind of relationships that students are using. So we're going to do an example problem talk on the Facebook Live tonight. It's going to be a little hokey because I don't actually have students live synchronous with me. So we'll do the best that we can to kind of sort of simulate what it would look like if you were in a live sort of Zoom or Teams or a WebEx situation with students. I actually worked with 50 teachers today that are using WebEx for live synchronous session with their students. I've been working with teachers that are also going to use Zoom. And last week I worked with a group of teachers who are going to be using Microsoft Teams. All of those have the capability of running a problem talk or a number talk the way that I'm going to kind of do it this evening. So thank you for joining me on our Facebook Live tonight, all about how we could do problem talks or number talks remotely. Tonight, I'm going to focus on multiplication. There's a couple different reasons to focus on multiplication. One, most adults have some purchase. They have some entry to multiplication. And two, it's awful fun to talk about. And so we'll sort of focus on multiplication tonight, and then I'll give you some other resources that you can use to think about problem talks and problem strings and how those are the same and different, and also how you can think about remote instruction. So hang on to the Facebook Live. At the end of the Facebook Live, I'll give you a link where you can download a page that I've got all about problem talks. Specifically, in this case, the examples I used were multiplication, but some things to think about with when you do number talks or problem talks with your students. All right, so thanks everybody for joining in. Glad to have, we got lots of comments, everybody saying hi. Super good to have you tonight. I'm gonna go ahead and share my iPad screen. So, I totally just did what I didn't mean. There we go. All right, I'm gonna share my iPad screen. Now, let me just tell you how I'm doing this. I'm actually gonna zoom that back out really quick. So I have my iPad hooked up with its normal charger cable. Oh, there goes my camera. Normal charger cord from my iPad hooked into my computer. Just the other end of it is the USB that hooks into my computer. If I was on my new laptop, I would have to have an adapter to get that USB to stick into my laptop. So however it is that you can get that power cable for the iPad hooked into your computer, then that just becomes the screen that I share. So no matter what sort of WebEx or Zoom that I'm using, that I want to share a screen, I'm going to share my iPad that's up on my computer. Now, let's say that you are in Zoom. Super easy. When you share screen, one of the options is iPad connected to your computer with a cable. That is probably the slickest way to do that. If you're in Teams or WebEx, you need to somehow get your iPad screen on your computer. There are a couple different ways to do that. One way, you could use an Apple TV. That's a little bit of an expensive way to do that. Another way you could do it that I'm actually using tonight is I'm using a product called Reflector. And I'm using version 3. Reflector 3, once I've plugged that iPad into my computer, I run Reflector, and then it mirrors my iPad onto my computer. So when I throw it like this, you're seeing my iPad. I'm literally sharing the screen from my iPad. I'll make it a little bit bigger. That's my iPad screen. So let's see if we can, there's my iPad screen. And so literally I'm just now sharing, when I go share my screen in whatever Zoom or Teams or WebEx that you're using, then I just choose the application that's mirroring my iPad to my computer. If you'd like to have more information about that, you can go to mathisfigureoutable.com. Maybe somebody will put this figureoutable.com. Maybe somebody will put this in the comments /how. There's some lovely verbiage there that I put some pictures and stuff about how I have connected and made all of this remote, being able to write as you're watching, how I make that happen as I do number talks or problem talks virtually with participants in workshops or students in classes, like students in my university class. All right, so I'm writing on my iPad. I'm writing with an Apple Pencil. I used to write with a stylus. Styluses work okay. They're definitely less expensive. They just don't tend to write as nicely. You might be looking at my handwriting right now going, Pam, I'm not sure about nice. Hopefully when we actually do the math, you can see that I can write pretty seamlessly. I'm also using Notability as the note-taking app. I kind of used to tell people, it doesn't really matter what you use, just to use a note-taking app. Y'all, they've just updated Notability. There are some really nice things I can do in Notability now in this new update. Like I can have what they call it's like a laser pointer. And so I can have it where you just saw it where it sort of had a tail, but I can also just have a laser pointer where I can just sort of point at things where it doesn't have a tail. I'm going to go ahead and turn the tail back on. I kind of like it because then I can sort of like arrow at things, and that's a way that I can kind of use that, and then it kind of disappears. So a way to have kind of this laser pointer to be able to point to things. Really, really nice. There's also a bunch of other nice things that I can do. Another thing in the upgrade that I just did recently is that you're now seeing Notability in kind of the presenter view. On Notability, if I click on the upper left-hand side, I can choose instead to just be showing my Notability screen. Now you're sort of seeing a normal Notability screen. Look over there, and in fact, let me use my it's not going to let me. I'm trying to use the pointer. So if I just point over here, this is kind of the button that I had pushed. When I push on that, then I can change back to presentation view, and then you don't see any of that top, all of that sort of menu stuff. It kind of disappears, and then you're just looking at a really, really clean screen. Wow, totally nice. So I really like the note-taking app Notability on my iPad, and that's where I'm going to record student thinking. So mathisfigureoutable.com/how is a place that you can go to read all about this setup that I just talked about, get all the details. You can, so go there if that's a happy thing for you. All right, so let's get right down to where we're going to talk about how I could use, let me get out of that. Whoops, no, go back to presentation, Pam, and go back up there. And let's get right down to a number talk remotely. All right, so I'm thinking that I've got my students in my Zoom or Teams or WebEx or however that is. I've got my students. All right, guys, now we're going to do a problem talk or what could be called a number talk. So I'm going to launch the problem. Tonight's problem that we're going to use is 15 15 times 18. So I'm going to launch that. I can write 15 times 18. I'm going to launch that problem to students. I'm going to say, students, go ahead and solve that problem any way you want. Use relationships and connections that you own to solve that problem. I'm going to give students a chance to solve that problem. Now, there's a little bit of discussion among my peers about whether number talks and problem talks should be all mental. So let's have a brief conversation about that. What does mental math mean? Well, I'm going to quote an elementary researcher by the name of Kathy Fosno, who says that mental math does not mean that you do it all in your head. Mental math means that you do it with your head. What that means is it's totally legal to keep track of your mental thinking. I think the reason that we've really, Steve, I know it's a good problem, right? So start working on that problem. And as soon as y'all that are on my Facebook Live tonight, start putting your strategies in the comments, and then we'll model some of those strategies. Because unfortunately, what I can't do tonight is like what I would like to do, which is get students to say their strategy. So we'll have to work on those in the comments. But back to Kathy Fosno, when she says mental math does not mean you do it all in your head. Mental math means that you do it with your head. In other words, it's totally legal for you to keep track of your mental thinking. So I will let students keep track of their mental thinking, but I will also highly encourage them to not use paper and pencil to just perform procedures, rote memorize steps. So I want to really encourage kids. It's just about keeping track of your mental thoughts. It's not about performing a series of memorized steps or mimicking what a teacher has shown you in the past. So I will let students have paper and pencil if they need to keep track or want to keep track of their mental steps. All right, so we've got some strategies that are starting to come in. Let me just share with you, if I'm on that live synchronous event with my students, I'm letting them solve the problem. And then depending on, I may or may not have them be putting things in the chat. There might be students who cannot unmute and turn their cameras on, or unmute and let me hear their voice. We might have some things at home going on. We might have too much noise for them to unmute. So in that case, I might have students type things in the chat. That's more difficult the younger the students get. My ideal situation is where I've built a sort of a community of trust, and I will have students literally in their windows, if they have their cameras on, put their physical thumb up, and they'll just sit there quietly with their thumb up that I have a strategy ready to share. And then I'm going to look for those thumbs. If a student doesn't have their camera on, I'm going to look for sort of their virtual thumb up. So on Zoom and on Teams and on WebEx, there's a way that they can hit an emoji, and it can just put like this kind of picture of a thumb, and I can sort of see those. Once I see enough thumbs, then I know that students have had enough time to work on the problem. Then I will call on students to share their strategy. So I might call on Kim Swaney Montague, who's on tonight, or Steve Heller, who loves 15 times 18. And I might say, ooh, Kim, what were you thinking about? But actually, now that I'm sort of thinking about Kim's strategy, I'm actually going to pause on Kim's strategy, and I'm going to ask her to share that one a little bit later. Let me sort of look and see what we've got going on. And so I might have Amy Rice share her strategy first. So Amy said that she was thinking about that 15 by 18. And I'm going to go ahead and model Amy's strategy like this. I'm going to say that Amy was thinking about maybe 15 by 18. Now, y'all, if I'm going to use an area model to represent this, please make that a rectangle. 15 by 18 should be a rectangle. It should not be a square. A 15 by 18 rectangle is a rectangle, not a square. So no, don't be drawing squares when we need to be drawing rectangles. Sometimes I think we draw squares and then we get like irritated at students when they're not reasoning. Well, if we're not reasoning either, I don't know if we have a lot to complain about. So I want to help students think about it as it's a rectangle, 15 by 18. And then Amy said that she was going to do, oh, don't give me too many or you're going to go off the comments. She said she was going to think about, let me just make sure. She was going to think about 10 by 18. Oh, that's a really nice one. Yeah, at 10 times anything, we can sort of think about that as 180. And then she was going to think about 5 times 18. Now, Amy, you don't know what 5 times 18 is. Well, a second Amy just put some help in the comments as well, where a second Amy said, well, sure enough, if you've got 10 18s, 5 18s is just half of that, right? Ooh, do we know half of 180? Now, again, I would be pulling this out of a student. I wouldn't be putting words in their mouth. I would be helping a student sort of talk about their strategy so they can just think about half of that, and then they can add the 180 and the 90 together. And is that 270? Absolutely. Okay, cool. So there's one fine strategy. I wonder what else we could think about for strategies tonight. So I'm thinking that we have a really nice strategy that's showing up, like, where did it go? Where did it go? Where did it go? Hang on just a second. I'm looking. Well, shoot, I'm pretty sure I saw it before and I just don't remember. So I'll go ahead and show what John said. So John said he's thinking about 15 times 20. Well, that's really interesting. So I'm going to go ahead and model John's thinking by saying John's also thinking about this 15 by 18. Hopefully that looks a little bit like the 15 by 18 that I had. But instead of thinking about 15 by 18, John's thinking about a bit more. He said to himself, I'm going to think about 15 by 20. Well, John must know 15 by 20. Can he think about 15 times 20? Maybe John's using 15 times 2 and then scaling that up times 10. So he could be thinking about 15 times 20, but maybe he's thinking about 15 times 2, then times 10. We call that the associative property. If he knows 15 times 2 is 30 and then scale that by 10, sure enough, then that would be 300. But then he knows he has this extra 2 by 15. That 2 by 15, I would say, John, what did you get? And he would say, well, that's 30. Ooh, look how nicely that 20 by 15 relates to the 2 by 15. Can you see how there's that? Let me get my cool pointer in here. That 2 by 15 is sort of showing up in the midst of the 20 by 15. So I sort of have 2 by 15, and then I could have the 20 by 15, and bam, those two, excuse me, not the 20, my bad. The 20 by 15 minus the 2 by 15, which would be what is left over, the 270. And so I might just sort of get rid of that part in there. If we kind of have the 300 minus that, we're going to kind of get rid of this bit over there. We're going to kind of hack that off. Ooh, a very nice over strategy. So we might sort of have kids kind of describe these strategies a little bit. We might call this kind of like a chunking strategy, or later, if I want to get a little bit more picky, let me get rid of John's strategy. Nicely done. We might call that a chunking strategy, or we might get a little more mathy and call it partial products. Now, I don't call this usually just partial products. I like to call this smart partial products, because check it out. What Amy didn't do was cut it into all the pieces, right? She cut it only into the pieces that she needed, like big, few chunks. Oh, that's a brilliant way. We want kids to be efficient. So we sort of call that smart partial products. We could also talk about, now I already forgot. It was John's strategy. We can kind of call that an over strategy. Really nice. Then I might look to see what else is happening. So now we might talk about what Dana's doing and what Kim is doing and what Fiona's thinking about. And so I think that's what you're thinking. Oh, maybe not. I might have to think about Fiona's strategy. Hey, Fiona, I think from down under, right? Love it when our friends from all over the place are joining in. So could we think about that 15 times 18 as, if I've got this sort of 15 by 18, that same sort of rectangle that we've been talking about, I think that Kim and a couple of other people are thinking about, what would happen if we cut that rectangle in half? So now I've just got 9, and then if I took this half of the rectangle and instead I sort of kind of tuck it under here. So I take this half and I sort of tuck it down under here. What would I end up with if I sort of took this half and I kind of move it down over here? Would that give me that'd be another 15 by 9? And so would I have a total of 30 by 9? Are you saying, Kim, that 15 by 18 is equivalent to 30 by 9? Ooh, nice. And then could we do some nice associative property stuff to talk about what 30 by 9 is? Can we think about 30 by 9? Now, again, I'd be pulling this out of students. We're on a Facebook Live. I can't have you guys join in and tell me what you're thinking about. So I'm kind of modeling what I would be trying to pull out of students. How did you think about 30 by 9? 30 times 9? I'm letting them talk. I'm going to assume that some of them were thinking about let's see, actually, let me write that as 10 times 3 times 9. And we have that sort of problem. And maybe then they use the associative property to think about 10 times 3 times 9. So is that just 10 times 27? Oh, nicely. And then we get that 270 popping out of what we call the strategy of doubling and halving. Very nice. So y'all, now we have 3 very fine strategies up here. Let me just sort of take a look at what some other people are putting up here. Lots of people are talking about how we can think about 5 times 18 with using 5 as half a 10. Brilliant strategy. I see several people using the over strategy. Very nice. So here's another example of the over strategy. Here's another example of the over strategy. I'm doing those kind of fast. There's another example of the 5 is half a 10 strategy. Let's see, we've got another example of the over strategy, another example of the over strategy. Very well done. Nicely done. Here's another example of the over strategy. Great, guys. Thanks for joining in tonight and giving me all of those comments. So I'm not seeing anybody give too many of the other strategies. We've got some great ones up there, some really nice ways of thinking about 15 times 18. Now, in a problem talk, in a number talk, I'm going to step back a little bit and I'm going to say, hey, students, we have 3 great strategies up there. What do you think? Which of these strategies do you wish your brain would be inclined to do next time, and why? What is it about these strategies that felt so nice for you? And then I want to have a conversation with students. What is it about, say, using smart partial products that really feels delightful? I would expect that maybe I'll just kind of ask that and then wait until I get some comments in the comments. What is it about that made smart partial products really feel really helpful here? Using 5 is half of 10. Ooh, such a nice relationship. Or why is it that so many people did the over strategy? What felt so nice about that? What made it really efficient and sophisticated, so sort of clever for this problem? And I might ask, what makes doubling and halving really sweet for this problem? Now let's see. I'm trying to think about Fiona's strategy about 40. So I'll pop up Fiona's strategy here. She said 40 times 4.5. 40 times 4.5. Fiona, you got me thinking about that. How did you get to 40 times 4.5? Class, can anybody help me? How was Fiona? What was she thinking about for 40 times 4.5? Where were those numbers coming from? So maybe if anybody wants to help me in the comments, help me think about, maybe Fiona, if you're still on, you can help me think about how are you thinking about 40 times 4.5? I'm looking down. Steve's got a nice flexible factoring strategy going on. We might share that one in a minute, Steve. 60 times 4.5. Oh, that's interesting. Where's that one coming from? I wonder if that 30 by 9 that we did in the doubling and halving, that 30 by 9, I wonder if I continued to double to get that, double that, 30 to get 60, and then half the 9 to get 4.5. That sounds like that might be something to do. Okay, Fiona, there we go. Cool. I was just checking. I was just making sure there wasn't something I was missing. Y'all, let's put up one more strategy. I think Steve was doing something kind of interesting where he's thinking about 15 times 18, and he wants to think about factors. Now, let me be clear. I don't really expect this strategy in 3rd, 4th, maybe even 5th grade. To me, this is more of a middle school strategy. I might expect kids that are really thinking multiplicatively to run something like this with factoring. So I think Steve said something about how 15 could be thought of as 3 times 5, and 18 can be thought of as 2 times 9. And then he rewrote that as 3 times, he's going to bring that 5 and that 2 together times 9. Why would he do that? Let's just pop. Let me get pop off of Fiona's strategy. Let me. Okay, there we go. Why would Steve do that? Why would he think about 3 times 5 times 2 times 9 and then pull that 5 and that 2 together? How is that helpful? Bam! 5 times 2. What's that, everybody? Does he just end up with a problem 3 times 10 times 9? Whoa! 3 times 9 is just 27 times 10. That's 270. What a fabulous strategy. Nicely done, Steve. And we can think about that as, sometimes we call it flexible factoring. In the past, I've been known to call it factor to multiply. What a cool strategy. Y'all, I really like that strategy for middle school kids because I really want them thinking about multiplication really multiplicatively, less partitioning the factors and thinking about them more multiplicatively. It's going to help us when we're trying to find common denominators and lots of other kinds of multiplicative things at the middle school level. So we might be having other things go on. Lots of nice things are happening in the chat, in the comments that you guys are throwing at me. But do you know what? In a number talk, in a problem talk, I'm actually going to suggest that 3 to 4, maybe 5 strategies is enough. Problem talks are meant to be relatively brief. They're supposed to be mini lessons, not really take over the whole lesson. We have other things that we need to accomplish in our standards. So I know a lot about my class now. I know a lot about kind of the relationships that you guys are using. But I'm also not going to pretend that I've just taught any one of you all of these other strategies. To me, problem talks are really good at me seeing what my class is doing. Really great pre-assessment. I get a chance to really feel what's happening in my class. It's also a really good opportunity for us to now have a conversation about comparison and efficiency. What about these numbers made those strategies work really well? Why can I use 4 of the major 5 strategies so well for this problem? So we're only missing really 1 of the major 5 strategies. You guys are like, what are the major 5 strategies? Well, we got 4 of them on there. What's the 5th one? I'll tell you in a minute how you can learn about all those 5 major strategies pretty quick. So let me just go through a few things that I think about when I'm thinking about doing problem talks or number talks with my students. So I think about the purpose of problem talks, which you just kind of said. It's about me pre-assessing. It's about us comparing for efficiency. And it's about Students sort of learning that there could be more than one way to solve a problem. Also, keep it short. They're meant to be mini lessons. Also, mental math does not mean you do it all in your head. Mental math means that you do it with your head. So it's totally legal to keep track of your mental thinking. However, I really want to encourage students to use what they know, not perform a bunch of rote memorized steps. If kids are doing that, then I might suggest like taking up their pencil. I might suggest, hey, no paper and pencil today. I'm seeing way too many algorithms. I might not say that out loud, but I'm seeing way too many kids doing stuff where they're not using relationships. Let's go ahead and set paper and pencil aside. But you guys, when the numbers get big enough, hard enough, then I want to let students use paper and pencil. A kid might not be able to do Steve's flexible factoring strategy unless they can kind of keep track of the factors as they're sort of factoring both factors. Something else to think about is that as the kids are saying their strategies, so notice you guys put your strategies in the comments just with numbers and words because you can't really put in pictures in a Facebook Live, right? Well, as I'm having a kid sort of describe to me what they're thinking, I have to make decisions as a teacher about how to represent that thinking. So this brings me to my next point. Y'all, it's about modeling strategies, not modeling models. It's not, if a kid says to me, oh, I did an array, then as a teacher, I'm going to go, okay, that's a model. And I'm going to say, what did you do with the array? Oh, well, I cut the 15 into 10 and 5. Oh, okay, cool. Then I will sort of model like we did here before, where I would model, oh, you cut the 10, and maybe I'll choose an array to do that. But depending on the numbers, I might not choose a rectangular array to model that. I could have also used a different model to model that strategy. I could have said, oh, you thought about 15 times 18 as you were thinking about 18s. And so you said, 10 18s is 180. And then you just cut that in half because 5 is half of 10. And so I cut that in half to get the 90. Nice. And then you can sort of add the 10 and the 5 together to get the 15, which was sort of our goal. And so you're going to add the 180 and 90 together to get the 270. I could model that same strategy on a ratio table, a different model. So it kind of depends on what strategies I'm anticipating students using and how I want to compare them. I really like the open array to compare the strategies that I was pretty sure were going to come out today for this particular problem. However, for other problems, like, oh, and by the way, I'm going to give you a free download with several really nice problem talks for multiplication. Several of these other problem talks I might model on a ratio table because they don't really lend themselves to arrays in order to compare the strategies that would be really nice for those problems. So as a teacher, I have to choose the model. If a student shares the same strategy just on a different model, then I'm going to model it one way, and then I might say, oh, so did you also use these relationships? You just had a different picture? Oh, okay, cool. I'll still give credit for the strategy, but I'm not going to put up necessarily two models for the same strategy. Or I might tweak that a little bit, and I might put up both models for the same strategy and then ask my students, y'all, what's going on? What relationships are they using? So like I might actually take this array. Let me see if I can do this. I'm going to try to be really techie here. I might take that array. Give me just a sec. I'm trying to be techie. And I might put it. Oh yeah. So Notability, I can sort of circle things. I can copy and paste them. So I might put those both up there, and then I might ask my students, hey guys, what do you see here? Do you see two models, two strategies? Do you see a model and a strategy? And then have the conversation about the difference between models and strategies. This is two strategies. This is a strategy using 5 as half of 10 with partial products on two different models. This is This is a ratio table. And this is what we call an open array or rectangular array or an area model. It's two different models. So as a teacher, I want to be clear on that. Y'all, if you're not clear on that, you can totally follow me on Twitter or Facebook. I do a lot of work. I'll put out about once a week, I'll put out something on models versus strategies, and you guys can get some help on that one. And the last thing I wanted to talk about tonight is in order to have a successful problem talk or number talk, you don't have to have all students share their strategies. Sometimes I'll do one of these and kids will be like, oh, I want to share mine. You know what? If I've sort of gotten my focus for the day, we've sort of achieved our goal for the day. I've kind of gotten a feel for what's going on. We've shared 3 to 5 strategies. I might be done for the day on that one. I might say, oh, you know what? Maybe tomorrow's your day to share. I submit we have honored all students' thinking by letting them solve the problem any way they want. And then because of time, I'm going to choose just a few strategies to share. Y'all, with an eye towards equity, I'm always thinking about equity. I'm making sure that when I'm looking for those strategies to share, that then when I see, ooh, this person, these people, these kids used 5 as half a 10, then man, I'm choosing between the kid that I haven't heard from for a while. I want to position that kid as a sense maker. So I'm always really thinking about equity. Allison asked a really good question. How do you choose which model to use? Allison, that's a topic for a new Facebook Live. So keep asking me that one, and we'll have to do that one another time. I'm up against a little bit of a hard break tonight, so I'm going to have to end in just a sec. Let me tell you where you can learn a whole lot more. So tonight, if you will go to mathisforgettable.com/mult Prob Talk. See how it's a multiplication problem talk? Y'all, I have a free download for you where I give you some examples of wonderful problem talks and then things to think about when you're doing problem talks with your students. So download that. Also attached to that is a one-page document about things to think about and prepare before you do a live synchronous session with your students. So 2-page free download when you go to that /mult prob talk. So maybe somebody could put that in the comments so you guys can just click on the link, mathisforgettable.com/mult prob talk. If you guys go to that, you can get a total free download, and then you can learn a little, read a little bit about problem talks, especially multiplication problem talks, some great examples, and then also a sheet on remote learning. Guys, the other thing I want to talk about tonight is if you are interested to learn more about multiplication strategies, like I mentioned those 5 multiplication strategies, if you want to get the lowdown on all those 5 and how to model them, Allison's wondering which model works better for which strategy, if I could invite you to my webinar this Saturday. So I've just changed that link. Notice the link down there just changed. mathisforgettable.com/webinar20. Y'all, I'm going to do an hour, maybe a little longer than an hour webinar this Friday night at 7 p.m. Central Time, Saturday at 11 a.m. Central Time, totally free, but you'll need to register. So register at mathisforgettable.com/webinar20, and I will lay out the 5 major multiplication strategies you and your students need to know to be successful at solving multiplication problems. So here, I'll show you on the website. You can, when you go to mathisforgettable.com/webinar20, you'll get to this screen where I'll tell you a little bit about the webinar, and then you can totally sign up for one of those 2 times. Click on the green for the time on Friday, click on the blue for the time on Saturday. Hey, let's say that you can't make it this Friday and Saturday. Let's say you're a real teacher and you are a little overwhelmed by everything going on at this time of the year. I hear you. Go ahead and register for the webinar, and then we'll totally send you a link. We'll record it, and you can watch the recording later. Y'all have been fantastic. Thanks for joining me tonight. I believe that we can help kids learn to mathematize using number talks, and I think they are a brilliant thing to use in our remote synchronous live instruction. Y'all take care. All the best. I hope things go well for you, and we will see you on at the webinar on Saturday. Ooh, I'm going to answer one more quick question. Claire says, how do you know who has what strategy? That's excellent. So one way to do that is to just ask, hey, did anybody, and now I kind of wish I had my other, oh, I'm going over, and my next appointment is not going to be happy with me. It's all good. It's all good. Let me see if I can get rid of that too. I might say to students, hey, did anybody use, trying to get rid of that. Did anybody break up the 15? I might ask students, did anybody break up the 15? Oh, tell me how you did that. I'm looking for students to put their thumbs up, and then I'm looking at who's putting their thumb up, and I'm choosing the kid that needs for equity, that I might choose that kid to position that kid as a mathematician. I'm choosing that. And then I might say, hey, did anybody think about doubling? And I'm going to try to say less about that, doubling and halving. All right, I totally have to go. Hard break. All right, everybody, take care and have a great one.